This problem is starting us off with a table of values here. It's given us the x values up top, and then our f of x values, our y values down below. And it wants us to find the value of the left-hand Riemann sum and use that to approximate this integral here. And then it's nice, instead of just telling us a number of intervals, they just flat out tell us the intervals that they want us to use here. When I'm doing a Riemann sum off of a table, especially on an AP Calc test, I like to just kind of bring that data down below here and put it on a number line. And the first thing I do is I go ahead and just mark off those x values from the table up above. So starting with my x values, I've got 0, then 20, then 40, and then down here I have 60. And then as I come through, the next thing I do is I just come and I take these y values and I put them above the x value they go with. So 0 would go with 5, 10 would go with 20, the 15 would be above the 40, and then this would be above 60 here. And then I come through and I just sort of label these gaps. So this is going to be area 1, that'll be area 2, and that'll be area 3. And I begin now just what I call sort of my assembly line process. Area 1 equals, area 2 equals, area 3 equals. Remember when we're doing Riemann sums that we're using the area of a rectangle formula. So the area of a rectangle is equal to base times height. The base is always the delta x value. It's the gap between your intervals. And one of the reasons that I like using the table down below here, or the number line over the table, is I can see as I put my number line together what these gaps are looking like. And oftentimes on tables, they can adjust the delta x so it's not a standard gap every time. So this one is a standard gap. The gap between 0 and 20 would be 20. The gap between 20 and 40 would be 20. And the gap between 40 and 60 would be 20. But on tables and on the AP Calc test, they are not always the same size gap. And so when I bring this stuff down to the number line, as I'm listing it off, it oftentimes, it'll sort of pop on you as soon as you start listing it. You'll see that it might not be a congruent or the same delta x every time. On this one it is though, so I know that the base on A1 is 20, the base on A2 is 20, and the base on A3 is 20. And then to find the height of these rectangles, the height is always coming from whatever that y value is. And the y value is always going to be a left or a right on this one. So here we're talking a left-hand Riemann sum. So when I look at A1, I've got the left endpoint on A1 and I've got a right endpoint on A1. We're looking for the left side of A1. So then on A1, my height is 5. Do the same thing on A2. On A2, I've got a left side and a right side. I'm looking for the left, and so the left on A2 would be 10. And then on A3 again, I've got a left side, I've got a right side. We're working with the left, so I'm looking at 15. And then from there, I now just multiply all these out and I'll add them up, and that's going to give me my approximation for the total area. So 5 times 20 is going to get us 100, 10 times 20 is going to get us 200, and 15 times 20 is going to get us 300. Add all that up and we end up with 600. And so that would be our final answer on this, which would be option C. So my recommendation is always to pull off the table, lay it out as a number line, and it just makes reading the data a lot easier. It also will sort of highlight to you when that delta x isn't the same between every gap. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.